Hello, welcome back to my series of videos on the frontiers of data science. And so today we are on to topic number 3, which is over parameterization. And so let me bring up that board. And okay, so the concept of over parameterization is a long word. Yeah, over parameterization is basically to to throw everything onto the wall and see what sticks. Like it's basically an overkill technique. Yeah, the technique of overkill. You throw as many variables onto the wall as you can and see what sticks. And then so that's the concept of over parameterization. But then on top of that, you lay the regularization method. Regularization basically means that you insert a penalty. So in terms of throwing stuff onto the wall, basically you are making the surface of the wall less easy to stick to. You make the surface of the wall very difficult for stuff to stick to. Yeah. So if you throw a lot of stuff onto the wall, that is very difficult for the stuff to stick to. So eventually, what still gets stuck there must be very powerful stuff. So that's the concept of over parameterization and regularization. So basically, you throw a lot of stuff, a lot of variables onto the wall, but the wall is very difficult for the variables to stick to. So whatever variables that are still left sticking to the wall must be good variables. And so that's the overall concept. But let me give you a very specific example. Like for example, football betting. Yeah. But before I start that example, the reason why we can do this by throwing so many variables, by using overkill technique to throw as many variables as you can onto the wall, the reason why we can do this is because of the advance in computing power. Yeah. And then, in the old days, even 20, 30 years ago, we couldn't do this, because if you have too many variables, then the computer will break down. Yeah. But the computing power is so advanced nowadays that you can throw many variables onto the wall and still ask the computer to find out what variables still stick to the wall. All right, so let's get back to the example of football betting. So in this case, you can find out as many variables as you can. Like for example, I want to bet whether Manchester United is going to win the next match against Liverpool. Yeah. And you can find out as many variables as you can. Like, for example, I can find out the style of the manager. I can find out whether the players were in the news recently. Yeah. And I can find out even some of those completely irrelevant variables. Like, for example, if they lost 3 away matches, then the next home match is going to be a win for Manchester United. Those are completely irrelevant statistics. They are relevant in the sense that they help you make a better prediction. But they are very difficult to interpret and they're completely meaningless. Yeah. And anyway, you find out even those irrelevant variables, those meaningless variables, those variables that are difficult to interpret, you still throw them onto the wall and see whether they stick. When I say whether they stick, that means whether they can make a good prediction for you. Because I want to, football betting is a big business, and I want to bet the big money on Manchester United winning the next home match against Liverpool. And so therefore, so that's the ideal of over parameterization, and on top of that, you add regularization. That means you make the wall a bit more difficult for the variables to stick to. That means you introduce the penalty on too many variables. And then so first of all, this kind of technique requires what they call a very sparse data structure. A sparse data structure basically means that not every football team, in this case of the football betting, not every football team has all the information for every variable. Like for example, yes, you may have information on the style of the manager for all the football clubs, and you may also have news on whether the football players were in the media recently. Yeah, you have that kind of regular news, but then you don't have information about, for example, say Everton, whether they have lost their last 3 matches, whether that will lead to a higher probability of winning the next home match. So not every variable has all the information you need to make the prediction. That's what they mean by a sparse data structure. Yeah. And then I'm not going to go into the technical details, but this is basically the idea. You throw as many variables onto the wall as possible and see what sticks. Yeah. When you say you see what sticks, that means you see which variables are going to make a good prediction for you. Yeah. But then you want to make sure that the stuff that still sticks to the wall is not completely irrelevant, completely meaningless stuff. So therefore you make the wall very difficult for stuff to stick to. And that's the technique. And then so if you want to go deeper into the programming stuff, the coding stuff, I highly encourage you to to read up on that, to do more research on that. But the video here is just to give you an idea of this is one of the biggest frontiers, biggest discoveries in data science over the last 20, 30 years. Yeah. And one of the biggest techniques in this area of over parameterization is what I call decision tree. And so decision tree basically is you go through all the variables, the variables that you throw onto the wall and see what sticks. So the decision tree is basically to go through all the variables. Like for example, on level 1, you say, okay, so this style of the manager, is it a very combative or very accommodative? Yeah. So then if you say yes, then you go to the next level question, which is are the medias were the players in the media recently? Yeah. And if you say yes, then you go to the next level of question. Like for example, the next level will be did Manchester United lose the last of 3 away matches? Yeah. And you say yes, then you go to the next level of question. Maybe is Manchester United likely to win the next home match if they lost the 3 away matches recently? That kind of thing. So you go through all the questions on these variables, and then if you say yes to all of them, then you can make a prediction. That means I can predict that Manchester United is going to beat Liverpool in the next home match. And yeah, so decision tree is definitely one of those over parameterized technique. And then to make the decision tree technique more accurate, to have a better prediction, they improve the decision tree technique by using, for example, adaptive boosting and gradient boosting. And these boosting techniques are basically very similar to the simulations technique that we talked about in the last video. Like for example, in simulations, yeah. Like for example, we said that simulation basically is if you have a limited amount of data, and you try to bootstrap the limited amount of data, so you get more data. So that more data means better training for your algorithm. Yeah, the algorithm to predict whether Manchester United is going to beat Liverpool in the next home match. And yeah, so I mean the concept is very simple. Over parameterization basically is you throw as much stuff as you can onto the wall and see what sticks. Yeah. And the regularization basically means that you make the wall surface more difficult for stuff to stick to. So therefore, what is still left sticking to the wall must be good stuff. Yeah. When I say good stuff, that means it's good for making accurate prediction in the football betting. All right. So that's a very oversimplified view of this discovery in data science called over parameterization. All right. So I'll see you in the next video, in the next discovery, next frontier in data science. All right. I'll see you then. Bye.